precision agriculture. Let's welcome.
Good morning. My name is Chai Wu. My English is not very well. I will try. And today, I will show you the presentation about the BDS in agriculture. My presentation includes three parts. The first is self-introduction. I got my bachelor degree in Henan University of Science and Technology. My major is agricultural machinery. And I got my PhD degree from Jilin University, and my major is agricultural mechanization engineer. And then I entered into the Institute of Land Sciences and Science of Peking University for my PhD postdoctoral research. And 2 years later, I became the faculty member in Peking University. And at that time, I began to use the data for agriculture and for other applications. Then, in 2012, I moved to China Agriculture University. I'm a faculty of the university now, through a talent program. So I returned to my old business. And in 2014, I have been to USA, to the Texas A&M University for 1 year as a visiting scholar. And at that year, I visited many family farm and several navigation companies. And my team includes 7 faculty members, and I am the team leader. We have about 38 graduate students. We took the picture, captured the picture several days ago on September 10, the Teachers' Day, Teachers' holiday, Teachers' Day, working day. Yeah. And we have 2 main research interests. The first is big data. I got a big project several years ago. The total funds is about 23 billion. And we encourage the agricultural machinery manufacturers to install the BDS terminal on the tractor, on the combine, and other machinery. And they all transfer their positional data for me. So I built a big data center, the only big data center of agricultural machinery in China. And I will show you some usage applications for you about the big data. And the second research direction is autonomous operating. Because in China, the labor cost is very expensive. So we needed to use the machinery to replace that labor. Although we have very, very large population, but the labor cost in the village is very expensive, and the number of the is very shortages day after day. So these the two direction is our research interest of my group. Also, I initiate a precision agriculture branch under CAAMM. CAAMM is the China Association of Agricultural Machinery Manufacturers. So many of the members, they come from the navigation company and agricultural machinery manufacturers. So I have very good relationships with the industry, and they trust me. They will transfer their data from me. So we have very good relationship with the industry in China, and I know out of the box of the we have a relationship. The second is that I am the expert of digital agriculture of the proper field of the Ministry of Agriculture and Rural Affairs. Nowadays, the government in China, they encourage many farms to build the digital agriculture demonstration. The government encourages the farmers to use the digital technology for their farms, to collect the information, to make a decision, and to adopt the appropriate technology to reduce the fertilizer and chemical usage. And last year in Chengdu, I got the Application Promotion Contribution Award of Beidou satellite navigation because I promote the Beidou usage in precision agriculture. I help the government to make the policy, the standard, and the demonstration project. Yes. So last year I got the award from the 11th China Satellite Navigation Conference. And I have been to Sudan and Tunisia and Europe for the international exchange in 2017 and 2018. Yes, I have been to Africa to exchange the idea data application in precision agriculture. And I wrote 2 books. The first is data application in agriculture. This is for the teaching material. And the second is the navigation and the positioning principle and application in agriculture. Yes. If you are interested in the 2 books, I can give you this afternoon. And I will welcome you in my campus this afternoon. And my graduate students, they are preparing for your visit. Okay. And the first is about my self-introduction. And the second is a region and concept of precision agriculture. Yeah, I'm not sure. Do you know the book? About 60 years ago, there's a famous book, very, very famous. And they changed the world development model. The name is Silent Spring. Was written by an American writer, Richard Carson. Yeah, we know the spring is full of relative, full of life, but because we used too much fertilizer and chemical, when you open your window one day in the future, you can never see the flowers and you can never see the birds singing. Why? Because we use too much chemicals. This material killed the birds and the plants. So the spring became silent. So at that time, the book changed the development model of the world. And many talents and the governments, they discuss how can we develop. But how can we adopt traditional agriculture model? We know our ancestors, they do not use the fertilizer. They just use the manual, farm manual. They do not use the chemical. They do not use the fertilizer. I think the answer is obvious, that we cannot change, we cannot return, we cannot go back to the tradition. Why? Because nowadays we have so large populations in the world. About 100 years ago, we just had 2 billion population, but now we have about 8 billion populations. So we need much more food to raise our population. We cannot go back to the traditional model. Then, how can we deal with the serious situation? We need to use the fertilizer and chemical, but it will kill the plant and kill the animals. So the answer is that we should develop sustainable agriculture, and we should to develop precision agriculture technology. This is the topic of presentation. We should to use the precision agriculture technology. Precision agriculture is a farming management concept based on observing, measuring, and responding to the inter and intra-field variability in crops in order to improve the crop yield and reduce environmental impact. Yeah, we need to use fertilizer and chemical, but we cannot use too much of them. So we need the precision technology to use these materials. That's the reason why we call it precision agriculture. So the precision agriculture, they need very high accuracy. Yeah, we need very high accuracy. That is the reason why we needed to use GIS. We needed to use the data. We needed to use GPS and GIS. This is the cycle of the crop field presentation, from harvesting to the water management and tillage, seeding, nutrient management, and chemical spraying. This is the traditional cycle. This is traditional. When we use the data for the proper field plantation, that we have the intercycle, and we improve all the top terminals. We built the new terminal for the tractor, for the combine, for the applicator. So this is the new system of precision agriculture, and I drew the picture. Draw the picture by myself. Okay, but we just told you that we cannot use too much fertilizer because they will damage the environment. But in China, we are facing a new problem, a very, very big problem. The left picture shows the agricultural production cost in China. From the picture, you can see there are mainly three parts of the cost. The first largest cost is the land transfer fee. And the second part is the level cost. And the third is the chemical, is the material cost. From the picture, you can see in China, land belongs to the government, owned state. The land do not belong to the farmer. They just use the land. So if you, how to say, the agricultural cooperative, they plant the crop, they needed to pay the land transfer fee for the farm owned the land. They not really owned the land. You know? Yeah, so they should pay the land transfer fee year by year. It occupied about 39%. So the land transfer fee is the first largest cost of the production cost. The second you can see is the level cost. And in China, the level we faces the level shortage year by year. All of the young men, they will leave the village, move to the city. So in China, usually you cannot hire enough level operators to work for you. And the third largest cost is the material, but they occupy very small percentages. So from the right picture, you can see this is a rice transplanter. Usually, we needed 2 to 3 operators to work for rice transplanter. One is the driver, and the second, the another is the helper to move the seedling. They help the driver to move the seedling. And last year in China, in Heilongjiang province, the cost of a driver is about 1,000 yuan per day. Yeah, 1,000 yuan per day. So the driver's cost is very, very high in China. And the operator, the cost of the operator is half of the driver, about 500 yuan per day. So if you have two operators to work for a rice transplanter, you should pay for them about 1,500 yuan per day. So it is very, very high. But if you use the machine, if you use the Beidou automatic steering system, the machine is very, very cheap. It's lower than that cost. That is why we needed to develop the automatic steering technology. That is the real. Okay. I will show you this. The third part, hot application of Beidou in agriculture. There are mainly three applications. The first is automatic steering. Automatic steering. And the first application, we use the machinery. We use the Beidou technology to replace the skilled operator and to reduce the labor cost. The second is the operation monitoring. And because the government will pay the subsidy for the farmers, and the boss of the agriculture machinery cooperatives, they need to monitor the cooperatives when they work in the field. So they need to install Beidou on the tractor, so they can calculate their operation area, and so they can pay the salary according to the operation area. The third is the precision operation. I'm not sure. Do you know that in China, the UAV in China is very good, and they sell to all over the world. We use the UAV to spray chemical to kill the pests. Yeah. So I will introduce three hot applications to you, and all of the applications they are how to say that every year we'll sell many products. Not for experiment, not for a demonstration. They just used in a real application. Okay, the first is about the automatic steering. I showed you two pictures. The first picture, the left, is the cotton picker. In China, Xinjiang is the main area to produce cotton. Yeah, and because the level cost is very high, so we import many cotton pickers from USA and to replace the farmer, to replace the ordinary. And also now in China, we can build the small scale cotton picker in China now. Some companies, they can build our own cotton picker. You can see in China, the serious problem is water. You know, in China, it's very, very dry. So they use the drip irrigation belt. They use the drip irrigation. So they want to enlarge the usage of the belt. So when they use one belt, they will plant the cotton beside the belt. And the two rows, the row spacing of the two rows near the belt is narrow, very narrow. So when you use the cotton picker, you need a very high planting accuracy, or you will miss harvesting the cotton. So the accuracy required is about plus and minus 7 centimeters. When you use the cotton picker, you need the planting accuracy less than from minus and plus 7 centimeters. But we know in China, the skilled operator, the skilled driver, when they operate the tractor, their manual driving accuracy is about plus minus 10 centimeters. So we can see that the accuracy of manual driving cannot meet the requirement of the cotton picker plantation harvesting. So we need to use the high accuracy, high navigation technology to meet the cotton pickers requirement. That is why we in China that the automatic steering technology is applied and popularized on a large scale in Xinjiang. Yeah, because we have two reasons. And the first is the labor cost. We reduce the labor cost. The second is because the cotton picker need high plantation accuracy. So you can see the two pictures. The left picture, you can see that is the manual driving. The highest accuracy is about 10 centimeters. And the right picture is from automatic driving. You can see straight. The road is very, very straight, very beautiful, very beautiful. And 7 years ago, I got a big project for Xinjiang, and the government can give me about a big project. And when the farmer they buy an automatic steering system, they can got the first subsidy from the government. The second, they can got the subsidy from our project. So many farmers they buy the automatic steering system, and the system, the price of the system also will drop quickly. So in China now, about one set of the automatic steering system is about 20,000 yuan in China. 20,000 yuan in China. And after the farmer get the subsidy from the government, they just needed to pay 2/3 of the sale price. 2/3 of the sale price. So in China, the farmer they can buy the automatic steering system, and for 1 year they can got the how to say they can save the labor cost, and the labor cost is higher than the price of the system. Yeah. Now I will show you 2 videos, one from USA and one from China, and they will show how the automatic steering system works on the tractor. Okay. Yeah, the title is auto steering really good for you, or can it get boring? If you stay in the in the tractor for 1 whole day, I think you will be very boring. But if you use the automatic steering technology, I think you will also become very boring. Why? Because you do not need to do many operations in a tractor. 对，这里。change it to auto still. So he's boring. Yeah. Plant cotton in 新疆。
这个新疆正是春耕播种的世界，这几乎是一年中最为忙碌的时刻。合众自创北斗导航农机自动驾驶系统，也在这里发挥着它不可或缺的作用。 合众自创北斗导航能机自动驾驶系统，可使农机的管理工作效率提高30%以上，农作物产量提高约5%，燃油消耗节约10%。其工作原理是通过 RTK 技术与车辆自动驾驶技术相结合，精确测量拖拉。
Antenna of 北斗 ，antenna of 北斗。
配置、航向和姿态，自动调整车辆转向，使车辆严格保持直线，设定曲线或自动规划路距形式，达到国际同类产品先进水平。在大大提高农机作业效率的同时，保障耕地、播种、喷洒和收割等农田重复作业达到厘米级精度，降低管理员的劳动强度，减少环境污染，增加单位产量，为农户带来了更多收益。该系统由7部分组成，主要部件分别安装在拖拉机不同位置上。自动驾驶控制
automatic controlling unit。
日期、农业性
display monitor。
日期、北斗
antenna。
GNSS 双天线、液压阀。
hydraulic valve。
车轮表
sensors of the front wheel to detect the angle of the front wheel。
传感器、农业机
base station。At that time, we built the single RTK station. Now we will use the network differential system.
自动驾驶系统软件
software. Software. This the straight line is the guidance line, AB line. 没事。不行，刚才我点了一下，没事，我就从这开始。
国外运营拖拉机转弯地头面积大，国内地头转
那个怎么了？他刚才那个。
国外运营拖拉机转弯地头面积大，国内地头转弯面。
重来一遍。哎，看能不能点到前面去。
安装了合众丝状回流道，奖励金是后将机动农场销售于。
在吗？前面。
改变着他的工作方式。新户农场以棉花种植为主，播种过程对作业精度要求非常高。合众丝状北斗导航农机自动驾驶系统作业直线精度2.5厘米，交接行精度2.5厘米。可自动驾驶在保证作业精度的同时，极大地降低了农机驾驶员的劳动强度。棉花播种作业过程包括覆膜、初期换代，需要经常停车接续，这是中国特有的作业特点。停车后重新起步，农机车辆能够继续保持直线行驶，无起无弯。国外运拖拉机转弯地头面
密。
面积大，国内地头转弯 棉花播种地头的环后，要求入水水短速度快。可重自创北斗导航无机自动驾驶系统产品，创新性的实现了前进、停止、倒车连续自动驾驶的作业方式，快速自动倒车路线距离小于10米。该系统通过底层自动算法，极大地简化了轿车所需要的时间和对场地的要求，只需平均70米道路，20到30分钟即可完成轿车过程。同时支持 AB 直线、圆圈、对角线等多种作业模式。2016年4月28日，合众自创汇龙北斗导航有机自动驾驶系统产品通过了10名专家组鉴定，一致认为该系统性能达到国际同类产品先进水平。合众自创北斗导航有机自动驾驶系统目前在新疆、内蒙古、东北三省、甘肃等地实现了规模化应用，照顾着千千万万的农民用户。汇农作为拥有完全自主知识产权北斗导航自动驾驶系统，对创造中国自主的现代化工业产品起到了很好的带动作用，在农村信息化和农机现代化的道路上迈出了艰巨的一步。
OK，目前还有视频，还有。So the automatic steering technology can reduce the labor cost. In Usually, we use the skilled operator. They need several years experience to operate the tractor. But now I think all of you can operate the tractors now. So it became very convenient for ordinary people to operate the tractor. So it can reduce the labor cost. And the second, the technology can improve the working efficiency. You can use the higher speed, higher velocity to operate the tractor. And the third, you can expand the work time. Now you can plant the seed. You make the plantation in the night, at night. Yes. Okay, from the automatic steering technology, some company, they upgrade the technology. They upgrade the automatic steering technology to the autonomous operating. How to say, is similar as the driverless operating. Yeah. Usually, we need 2 to 3 operators to operate the rice transplantation. But now, only one person is enough for one machine. So it can sell the 1 to 2 level. Okay. I will show you my team's work for you. The driver is doing the deep tillage working and no operator. You can use the mobile phone to control the tractor. It will navigating along our route, planting route. It will stop and lower the engine and make U-turn. So our idea or our object is one person to operate several machines. When the tractor finishes the U-turn, it will lay down the implement. So we can image maybe several years later. You can drink coffee under the umbrella, and you can use your mobile phone to control the tractor, and it will automatically work for you. Yeah. So our idea is one person for several machines to reduce the number of the lab, to reduce the labor cost in further. This is our thought, our idea, our object. Half of my graduate students are work for the machine. Yeah. Okay. During the past several decades, the technology moved from manual driving to automatic steering, and now we are developing autonomous operating technology. So when we adopt the autonomous operating technology, we needed to build the new standard, of vehicle, machinery, field, and road. So this year I provide a suggestion for the Ministry of Science and Technology, and maybe I will got a project about for all. We develop the technology from the office to the field. Yeah, we develop all of the technologies to control the tractor, and they can safely move from the moved from office to the field, and when they finish the work, they can go back to the office.哦，那要不要休息一下？休息一下，40啊，需要吗？
行，他一般的是那个中间休息一次
啊，
您看您的时间。
休息一下啊。Let's have a break. Second part is about operation monitoring. Just as I said, we encourage the manufacturer of agricultural machinery to install the Beidou terminal on their tractor, on their combine. Yes. When we got the data, the position data from the agricultural machinery, we have many usage. Yes. We can calculate the operation area, and we can review the operation quality and issue the operation subsidy for the farmers. So we install the terminal on the tractor, and then the Beidou terminal will transfer the data from the position from the tractor, or sometimes from the implement. The 3G or 4G, through 3G or 4G, we can obtain the data from the vehicle and then save it in the service. In the service, then we can make many applications. We develop the software for different sectors, for different users. The first example is about the cotton picker monitoring. In China, almost all the cotton picker companies installed a Beidou monitoring terminal and system. This is the terminal, and the terminal can obtain the Beidou's position and to get the rotation velocity of some parameters from the cotton picker. And then with these data, we can make the software to monitor all the cotton pickers, and the company can make a dispatching the cotton pickers. Yeah, so, and they can calculate the operation area of each of the cotton picker, so they can pay the salary for the operators according to their operating area. Yeah. The second example is from my team. I have a customer. The customer is a dairy holding company. They own 73 class forage harvester, and it's very expensive. It's 2 million yuan per machine, very expensive. And they bought 73 the forage harvester. Yeah, and they have about 500 pieces of agricultural machinery. And they invite me to install the Beidou on all of their agricultural machinery. And I built the software for them. So they can monitor all the work of the agricultural machinery. Yes. And the boss told me that they should be the largest agriculture company in the world because they have 40,000 hectare field, very, very large, lies everywhere in Liaoning province. Yeah. In China, the government encouraged the farmers to do deep plowing, straw returning to field. Take deep plowing, for example. Under the soil, there is a layer very, very hard. So the government encouraged the farmers to break the hard layer. Yeah, it will cost more fuel. So the government will pay subsidy for the farmers. And the government require the farmers to install Beidou on their tractor so it can calculate the operation area. And the government will pay the subsidy for the farmer according to the area. Yes. Okay, and for the agricultural machinery manufacturer, they installed the Beidou terminal on their tractor, and it is also useful for themselves. Because in China, the manufacturer is needed to provide 3 packs of quality service for the product. When you sell your combine, you should freely provide the parts, provide the maintenance for the farmers. So the manufacturer, they are interested in the position of their products. So when they got the call from the farmers, they can provide, they can dispatch their service car to help the farmer to resolve the problems. For example, to replace the parts, to provide the maintenance service for the farms. Yes. So the manufacturer, they are also very interested in machinery positions. Yeah. When all of the machinery installed the Beidou terminal, they will transfer the data to me. So I built a computer room. Yeah, sorry. So I have a computer room for the big data, and I bought many server for the big data center. And I got a big project supported by the government to save all of the data from different manufacturers. And then I built a platform this is the monitor page of the big data. And now we have more than 25,000 pieces of agricultural machinery. Yeah, and this afternoon you will see my students will show you the terminal and will show you the software. Okay, and my students will introduce this afternoon to you. Okay, and through my big data, I can provide different kinds of service for the government, for the manufacturing, and for the farmer. For example, for the government, yes, the government through my big data center, they can master the wheat harvest progress. And for the farmer, for the operator of the combine, they can arrange harvesting progress scientifically. And for the manufacturer, they can allocate tasks and maintenance resources around the harvest hotspots. I will show you many pictures. These 2 pictures is the hot map of the combine during this summer. For example, June 5, we will we will produce 3 hot maps. We will build 3 hot maps. So you can see where is the combine in China on June 5th. And this is also the hot map of different days. So you can see that in China, this area plants winter wheat, and the wheat in the south province will be harvested earlier than the north. So the combine, they will move from the south to the north about to 1,000 kilometers. So they can move from south to north to harvest the winter wheat. And the government should provide some service for the combines. And also the manufacturer, they will provide the service for the combine. So, and also the harvester, they can find their market. They can contact their customers through our hot map. And they also know where other companies are working. Yeah, this is the hot regions. The hot regions will move from the south city of Henan to the north city of Hebei. So different day, the hot regions will change from the south to the north. Yes, about more than 200,000 combines. They will work from south to the north. Yeah, very large amount of combines. And the right picture shows the operation efficiency. You can see most of the combines, they will, the operating area per hour. You can see the operation efficiency. This is the harvest area of the current day. You can see through our big data center, we can give the operating total harvesting area of a city. Yes, of a city. This is the harvest area of the regions. Okay, I will show you 2 trajectory of the combine. You can see that this is one of the champagne of the current day. They will harvest the winter wheat for 1 day. This is the trajectory of one combine. This is another trajectory of a combine. Yes. Then I will show you the champagne of the whole summer. The total area of one champagne, they worked for about 1 month, and they moved, the distance they moved is about 1,867 kilometers, and they harvested totally about 4,367 acres, Chinese acre, 1/6 of the American acre. So the area should be divided by 6. This is acre, and you can divide it by 17 is the hectare. So this is the champagne we got from our big data center, and we can know all of the combine their operating area during the summer. Yes. Okay, I will introduce the third application. Hot application is about the precision operation. For example, based on the high precision position of Beidou, we can realize the variable sowing, variable application of fertilization, and variable pesticide application, and precision harvest. Yes, if when we have the high accuracy position, we can improve our operating quality of seeding, of fertilizing, and spraying and harvesting. This is Chinese brand, and they upgrade their CEDA by using the Beidou position and velocity. So when they use the Beidou velocity, they can accurately adjust the sewing front spacing and monitor the seed drop. They can calculate, they can count the seed drop for each seed. And based on the Beidou location and the prescription map, we can realize the variable rate spraying. And sometime we will build the prescription map for different level of the pesticide. So we can upgrade the sprayer to realize the variable rate spraying. The third application of the precision operation is the UAV for plant protection. In China, just what I said, that UAV is very good in China, and many farmers, they will use the UAV to spray the chemical. I think the UAV is not suitable for the corn because the corn is very high, and the pesticide may lay yes, how to say? So, but the UAV is quite good for the wheat, for the rice, and for some very not very high plant. So in China, that some of the UAV they installed the RTK terminal. Do you know RTK? The RTK can provide the centimeter level position. So when we install the RTK terminal on the UAV can realize the autonomous operating. Just like my tractor, you can use the mobile phone to control the tractor. So, and also you can use the mobile phone on the terminal to control the UAV, and the UAV will fly along the planting route, yes, and with very high accuracy, So you can see we use the UAV to spray. Okay, thank you. That's all my presentation.
Thanks for Dr. Wu's presentation. And we have some questions from online trainings. 这有一些问题，您帮我回答一下。
Yeah, for the first question, can we convert an ordinary tractor to automatic driving tractor? I think it is not a simple work. So sometimes we will use the new tractor to equip the automatic steering system. The main problem is about the 我查一下，它叫变速箱。
Gearbox transmission.
Transmission is very important. Usually you need to manually transfer the transmission. So if you convert a tractor to automatic driving, I think it's not a simple work. But how to say? Oh, I'm sorry. Not autonomous driving. You just asked me to convert the tractor to automatic driving. Of course, almost most of the tractor you can convert it to the automatic driving. No problem.
The second problem is how the RTK signals are obtained in automatic driving. Yes, in China, several years ago, the farmers will build their own single RTK station for their tractor. But nowadays, the farmer do not need to build their own RTK stations. They can use the commercial service from 千寻位置, 千寻, they have the commercial service for the RTK service. We just use the SIM card and you can get the differential signal from 千寻 network cost. Okay. I think maybe in your country, Sri Lanka, maybe you needed to build your own RTK station. Whose question?
No, this is from online training, not offline.
OK，
这是线上的，
好，
线上的。
好，
这是刚才那个问题，我摘的。
好。What would be the cost of entire conversion of normal tractor to? Yes, in China, I just told you the sale price of the automatic steering system. In China, maybe is about 20,000 yuan. That may be about $6,000 US. Yeah, the price is of the automatic driving system. The third question is about Sri Lanka. We have very small field size. How applicable the automatic driving system in Sri Lanka? Yes, in China, in the Xinjiang and the Heilongjiang province, they have somewhat large field. So the automatic steering system was popularized very quickly. And also in China, in a southern province, just nowadays, how to say, not very much farmers use the automatic steering system. I think if the field is very small, it cannot, how to say, it's not easy to use the automatic steering technology. Thank you.
说就是他们就是有一些这个 RTK 站，但是应该不是很多。其他的没什么新的东西。Okay, so if you do not have further questions, that's for today. Let's thanks again for Dr. Wu's lecture. Okay, thank you.